Orb-2 mission to the International Space Station. Orbital Science's Cygnus cargo spacecraft is on its way to the space station. The Antares rocket lifted off today at 12:52 p.m. Eastern Time from the Mid-Atlantic Regional Spaceport's Launchpad 0A here at NASA's Wallops Flight Facility in Virginia. Cygnus is scheduled to arrive to the space station Wednesday morning. Here to talk about today's launch are William Gerstenmaier, NASA's Associate Administrator for Human Exploration and Operations, and Frank Culbertson, Executive Vice President of Orbital Sciences. For those of you watching on TV or through the web, we'll take questions from social media. To get those questions to us, you can use the hashtag AskNASA. And let's start with you, Bill.
Okay. Thanks, Rachel. Again, it's a great privilege to be here to see the launch today of the rocket, and things went really well. And again, a tremendous team effort between the Mars team, the Wallops team, and the orbital team to make this launch occur today. The countdown was extremely smooth, went very well. Again, I think that shows the team's preparation of getting everything ready, and all the ground equipment worked extremely well. The range went really well. The weather was good, and just a tremendous launch. We're looking forward to the cargo getting to the space station. There's a lot of experiments that are going up for the crew, as well as some needed equipment, and then lots of food for the crew. So this will be great to see this equipment get on orbit, and it's great to see this team come together and work. And congratulations to Orbital and the whole team down here for just a wonderful launch today. Frank?
That's all, Bill?
That's it.
Okay. All right, well, good afternoon to everybody. It's a very exciting day for us. And Bill Robel, I think we've found the secret to getting people's attention here on the eastern shore of Virginia, Maryland, and Delaware, and that's to launch on a Sunday in July. And I bet you have never had a traffic jam on a Sunday in Chincoteague. And there's a lot of traffic out there right now. And in fact, just looking at the number of rookie reporters we have here in the room, I have never seen this room so jam full. And so I appreciate everybody coming to watch this, because spaceflight is exciting, and it's a great thing to experience. It's a great thing to be a part of. It's also a great thing to take your kids and family members to see, because it's inspiring to see what U.S. and international ingenuity, innovation, and engineering can do. And we've done some great things, and today was an example of one of those. It took a lot of effort for people to pull this off. We worked a lot of problems over the last couple of months that had to be resolved, and even today, as we were working through the countdown, small things came up and people had to figure them out. Sometimes we had a procedure for it. Sometimes we had to say, we've never done this before, but we'll figure it out and we'll get it fixed, and we did. Between the teams that are involved, as Bill said, Mars, the Wallops team, our orbital team, several business units involved there, led by David Thompson, our CEO. It's been a really proud day for us to be able to pull this off. We had things like a couple of sailboats that tried to get into the area, and the Coast Guard went out to try to turn them around. And one of them didn't want to turn around. I don't think they believed them, but we finally saw the little Vector go a 180 like that. Maybe they threatened them with something. I don't know. But anyway, they cleared the range, and we proceeded, and we launched exactly on time, as was planned. We've got a brief video here to show you some of the highlights of the final seconds of the countdown and the liftoff of Antares, and I think it's showing now. You can see the rocket on the pad. Right before ignition, we inundate the flame trench with water to protect it and to protect the surrounding hardware. The rocket comes off the pad. Majestic is the way Mr. Thompson describes it. Slow is what I say, but I just like to see it clear the ground and get going. But it is majestic, and it's a beautiful sight to see it lift off into the atmosphere. We did have some clouds at medium levels that kind of obscured it for people trying to watch it today, but we had good instrumentation, and everything looked great in the first stage. We burned the first stage for almost 4 minutes. Everything was, as you heard from Kurt Eberle, nominal as we climbed into the sky. The first stage was powered by 2 AJ-26 engines provided to us by Aerojet Corporation, Aerojet Rocketdyne Corporation, and they performed flawlessly. The first stage itself is built by Yuzhnoye Yuzhmash in Ukraine, and one of our international partners, and it also performed very well. Once we reached, and that didn't really happen, once we reached the end of the first stage, is that all of it?
That's it.
Oh. Once we burned all that fuel, we separated between the first and second stage. The second stage, powered by an ATK Castor 30 engine, ignited a few seconds later and then took us all the way into orbit. And it also performed flawlessly and put us right on the right trajectory. We ended up with about a 284 by 190 kilometer orbit. That's the perigee and apogee. And that allows us to stay in orbit long enough to do a couple of burns to refine that orbit so that we can begin the chase to catch up with the International Space Station and rendezvous with it. We have completed the first burn. We have another one coming up before too long. We've deployed the solar arrays, both of which locked into place, and we're getting full power. And all the systems on the spacecraft are operating nominally, and as we expect them to. So we're very excited about the fact that we're in orbit and we're headed to the station. We've got over 1,600 kilograms of cargo. As Bill said, it's a combination of experiments, food, clothing, general supplies for the crew. A lot of student experiments on board, a lot of CubeSats for various organizations, including universities and other academic organizations. And so we're very excited to be able to contribute to the continuing research on the station, as well as spreading the ability to conduct research to various citizens around the world, not just Americans. It's a great opportunity for the company. We're very proud to do that, and we're really looking forward to the rendezvous, which will occur Wednesday morning. That's another delicate procedure that has to be conducted, much of it autonomously, but closely watched by our mission control team in Dulles. And as we approach the station, we will stop at about 10 meters away from the station. At that time, Reed and his crewmates will grasp the station with the robotic arm, attach it to the lower side of the node 2, and attach it firmly, and then open the hatch and start pulling out their new clothes and food, and hopefully be very happy about everything they find. It's like Christmas in July. I always wanted to use that phrase. But it'll be an exciting morning also for our team, and of course they're hard at work right now making sure that all the systems are working right. The Antares team, of course, is closing up their notebooks and leaving the Mission Control Center, and I don't know what they're going to do tonight, but they'll probably be really happy. And they've been waiting 2 months to get this one off the pad, and that includes the NASA and Mars teams also, who work very closely with us. So again, my congratulations to the entire team. Bill, thanks for the cooperation and collaboration with NASA. You're a great customer. And you believe that, right?
Yes.
Okay. And we certainly are really, as I said, proud to be a part of this endeavor. The space station is extremely important. It's an international space station. The international cooperation there, I think, is something people should pay more attention to. The ability of the space program to make sure that, or to enable countries to come together and do something that's extremely difficult, do it successfully, do it with a lot of cooperation and trust, which is really the key to us being able to be successful, is a great example for the rest of the world to follow. At Orbital, we have the same thing with our international partners that contribute to the success of Antares and Cygnus. Pressurized cargo module is built in Italy, and same company that built some of the modules on the station. And a number of others who provide components. So we try to work with the best in the world, and we're looking forward, of course, to continuing to be an American company that leads in the commercialization of space. And we appreciate the opportunity. We're looking forward to the next 6 missions and the next contract, and go Antares and go Cygnus. Thank you.
Thanks, Frank. Okay, we'll take some questions here at Wallops and on the phone. And as a reminder to those watching from afar, you can send us your questions on social media using the hashtag AskNASA. We'll start here.
Hi, thank you. Ken Kramer for Universe Today. Talking about contracts and the future. Frank, last time you were thinking that the space station could be extended a few decades. I'd like to ask Bill, what's your perspective? Can you philosophize a little bit about extending the space station and the importance of these cargo missions? And also, the next step with the contracts. Tell us what's going on, when you're gonna do that, how many companies might be involved. Thank you.
Okay, sure. The station's been extended from the administration standpoint to 2024. We see that as a pretty monumental step. If you think we're in 2014 and then 10 years is a nice window for researchers to go ahead and build experiments, to go utilize station. We, from a NASA standpoint, see the space station as being extremely important to exploration kind of activities. As you think about going beyond low Earth orbit and you want to go out to Mars kind of distances, what a great platform to learn about microgravity, and that's the space station. So you can learn how the human body operates for extended period of time. Next year we'll do the 1 year increment with 2 of our crew members on board station for 1 year, so we'll get the chance to see that if there's anything that happens with the human body that changes beyond 6 months. We have a lot of experience at 6 months. The Russians have flown crew members to a year, so we know that there's nothing major can happen, but we're really looking for those subtle little changes in the human body that might really impact a Mars-class mission, and that's where that 1 year increment will be important to us. Also, our systems that we operate on board space station, they have to be extremely reliable. You know, with station, we have to repair a lot of components fairly regularly. There's a lot of critical components that are actually on this Cygnus that's going up today that are important to go change out. And when you go to Mars, you've really committed yourself that those components, everything you need really needs to be with you as you go. So to get a chance to experiment on long life, high reliability components is another real strong aspect for station. So again, we're going to utilize station as much as we can during these next 10 years. Again, you know, I optimistically think that once folks start seeing how station can be used, it'll get used more, and we'll see station get extended even beyond the 2024 timeframe. You know, we're putting in place some of the contracts for that. We got the commercial crew transportation contract that we're working. You know, we're trying to award sometime in August, September timeframe. That's been our normal schedule. We'll select 1 or more contractors for that crew contract. Cargo contract, we just put out a draft or request for proposal from the contracting community. They have over the summer to give us comments back to that draft proposal. We'll then finalize that proposal sometime in the fall with the idea to select sometime towards maybe December, January of next year for the second phase of the cargo contract. So again, I think it's a pretty robust time. I think what's really exciting is if you look at the science that's getting done on station, this is probably the most productive science period I've ever seen on station. And I see a lot of student experiments. You can get the details from the press kit and go look at which high schools are participating, which kids are flying experiments to station. And these flights that are occurring fairly soon, you know, there'll be an ATV launch here at the end of this month. It docks later in August. Then there'll be a SpaceX launch in the fall. That routine of flying every couple months allows a lot of experiments to get to orbit fairly quickly, which is important for researchers and important for students. So they don't have to wait 3 years before they get results back from their experiments. They can start seeing results from their experiments fairly soon. So I think this is a very dynamic time. You have to work a little hard to understand what's going on with station, but I think it's really worth your time to go out and look at the web and spend a little bit of research time and go look. And I think it's also really cool to see here from Virginia, right? We're actually launching from here to the International Space Station in the international venues that Frank just talked about. So think about how we've really touched kind of the Virginia East Coast or Eastern Shore here and really have changed, I think, the way things are working. So you can see benefits of the space program right here on the Eastern Shore. So it's kind of cool.
Let's go to Frank here.
Hi, it's Frank Mooring with Aviation Week. For Bill Gerstenmaier, a question about the logistics that are playing out with these commercial cargo vehicles. Are you meeting your marks? Are you confident that you'll be able to do that through the life of this first contract, both with Orbital and SpaceX? And then for Frank, I wonder if you could tell us a little bit about the upgrades that you have planned for the Cygnus cargo vehicle, when you're going to start bringing those on board.
Sure. Again, you know, I think we kind of planned that it might take a little while to get some of these cargo vehicles established. You know, it's not easy launching a vehicle to space. There's you know, even though the vehicle is ready and fully designed to get into kind of a cadence or routine of launching regularly, it doesn't happen quite as easy as you think. And you've seen that occur. Frank talked about his team, you know, working a couple months extra from when they were originally going to go plan. You know, the test stand problem really really challenged the team to go look and make sure that we're really safe to go fly and move forward. We had enough margin on station that it was okay. We have enough vehicles between SpaceX and ATV and Orbital that we're okay. I tell you, I can breathe kind of a sigh of relief with this flight. There was definitely some food and some other things that the crew needed. There's also some components for the Japanese module that are important. There's some other upgrade things that are really important to get to station. So this flight, I think, I feel really good that it's occurred now. We had some margin, but it was getting to be where it was a little tense where we are overall. We knew ATV was coming online, but you like to have a little more margin than that. So again, I think this next year will be really important to us that we kind of establish a cadence of routine flights, and that's not easy. And we've got a little margin so we can grow and not push too hard, but we need to get in kind of a cadence of where we're flying regularly with the cargo flights. And Frank?
And that's important both to NASA and the station as well as to the providers. The companies that are doing this are doing it under fixed major delays is a big deal for us, and so we are trying very hard to achieve regular production and do it cost effectively. In order to continue to improve on what we're doing and carry more and more cargo to the station, we do have a product improvement program we've been working on, and we have an enhanced version of Cygnus that will begin flying next year. We're actually upgrading the Antares on the next mission, and we'll be able to carry an additional 500 kilograms of cargo on that one. It's still the standard size PCM, so we won't be able to take full advantage of all that performance. But on the following mission, Orb-4, we'll have a pressurized cargo module that's a meter longer, and will carry about 700 kilograms more than the current system. And we have some additional changes, such as new solar arrays, some different radios, lighter weight components, all adding up to increased performance and higher cargo capability for the station over the remainder of the contract. And yes, we will be able to meet our 20-ton goal over the 8 missions.
Let's go to Marcia.
Marcia Smith, SpacePolicyOnline.com. Following up on Frank's question, I'm curious, I think, is this the last ATV flight that's going up? How many Dragon and or Cygnus flights does it take to equal an ATV flight? I'm curious what this means for the flight rate in the long-term future when there won't be any more ATVs, and how many HTVs are left?
Yeah, this is the last ATV, and I'll have to go check on the HTVs, but there's roughly, I think, about 4 left on the HTV line. We're still negotiating with the Japanese on those. And again, it depends which version of Cygnus you take. If you take the enhanced Cygnus that Frank talked about next year, it's roughly maybe 2.5, I believe, Cygnus kind of vehicles to equal what's in an ATV. What's unique about ATV is it can carry a lot of fluids. It can carry water. It also carries propellant for the Russians to refuel their system. HTV is unique in the fact that it carries some external cargo, a little bit like the Dragon does. So we have a nice mixture between all these. And so when we looked at it, there wasn't really a big need for the unique capabilities of ATV, so this was the right time to phase out ATV. And so this will be the last flight of ATV, and then we'll continue to fly HTVs and Cygnus and SpaceX Dragons.
Let's do one more here in the room, and then we'll go to the phone.
Could you tell me the fate of the first stage rocket? I know it goes into the ocean, but how far downrange? And does it just land ballistically, or are there parachutes to slow it? And secondly, does the second stage remain attached to the payload until it returns?
The first stage does return, or does land in the Atlantic ballistically. We clear the range to make sure that people are in fact clear of that area before it comes in, and that's one of the things we have to watch during the launch countdown. I don't remember exactly how far downrange. Yeah, however far that is, near Bermuda, but not very near Bermuda, but kind of that distance. And then the second stage, once it separates from the Cygnus spacecraft, remains in orbit for a certain amount of time, and then it'll re-enter destructively, usually within a few weeks. But we make sure that anything we put into orbit that is going to be there for any length of time is not going to stay on orbit. It's going to return so that we don't have an orbital debris issue.
Okay, let's take a couple from the phone. I think we have first up Bill Harwood with CBS News. Go ahead, Bill.
Yeah, thank you, Rachel. One for Mr. Gerstenmaier, if I can. When you were saying a minute ago things were a little bit tense from a supply standpoint, I was under the impression you guys wouldn't hit your 45-day countdown timer until August, and that with ATV and Progress coming up here pretty soon, you guys are pretty fat on supplies. Am I missing something there? I just want to make sure I understand how to characterize it. Thanks.
You know, I mean, again, from a requirement standpoint, we had the right skip cycles protected, and we had time until the fall. But I guess kind of from a pragmatic warrior standpoint, even though we had till the fall, knowing the problems we had with some of the test stand things, some of the challenges we've been working on the other side, and then also the French Guiana gets kind of jammed up with a lot of commercial flights on the European side, you could see all that margin evaporate pretty quick. So if I wanted to worry a little bit, right, I could definitely worry myself into wanting to get a little more margin. So we didn't really have any problem till the fall, so probably overstepped a little bit by saying I was concerned, but I will tell you that there were enough things there that when I add them all up, it was a time that you want to make sure that you're really ready to go fly. You don't pass up an opportunity lightly.
It is rockets, not airlines.
And Bill, do you have a follow-up question?
He's thinking.
Okay, let's go here in the middle. And then we'll take a couple from social media.
Hi, my name is John from Countdown Today. Antares Cygnus was named for astronaut Janet Voss. Who names each spacecraft before their flight?
The executive team at Orbital picks the name for each spacecraft, and we have not announced the name for the next one yet.
Okay, let's take a couple from social media.
Sure. The first question is from Keith on Twitter for Frank. Frank, what are some of the experiments this mission is carrying to the ISS?
We have some student experiments of various types. There are some CubeSats. There's the, TechSat 4?
TechEdSat 4.
TechEdSat 4. I don't recall all of them. Frank, do you remember any of them? 30-odd CubeSats that will be deployed from inside the station. Not all at once, I don't think.
Go ahead.
One more question for Frank from Twitter. How long does the docking process itself take?
The docking process itself takes about, would you characterize it as 8 hours, Frank? 6?
Yeah, 8 hours.
Okay. The final portion is about 8 hours when you're approaching the station, and the last 4 hours are when you're fairly close to the station and you're approaching fairly carefully from below, and then the last 250 meters are the final approach, where you'll stop at 10 meters, and then once they've grappled, it'll take them about an hour to attach it to the station firmly and get in a position where they could open the hatch if they wanted to.
Okay, we'll take one more from the phone and then come back here for a final question. On the phone, I believe we have Stephen Clark with Spaceflight Now.
Hi, Rachel. Thanks. 2 questions for Mr. Culbertson. First of all, in the launch video, it looks like there's a little bit of a tilt of the vehicle coming off the pad. I'm not sure I've noticed that before. Is that a normal maneuver or something unexpected? And secondly, for Frank, how soon do you plan on announcing a new long-term provider for Antares first stage propulsion? Thanks.
Well, for the second one, we're still in the process of negotiating with the proposers on the next block of engines for Antares, and we'll probably announce that sometime this summer. And you were asking about what some of us call the wiggle off the pad. Others call the Baumgartner maneuver, but it was a little more pronounced today, or maybe we could just see it better. But as the rocket lifts off, it actually moves the tail of the rocket closer to the structure, so that it then flies away from the structure, and that's to protect the tail and the surrounding hydraulic equipment and electrical cables from the blast of being too close to the rocket. It's only a degree or so, but it is sometimes visible depending on the viewing angle. Yes, it is a hard stopper when you see it and you don't expect it, but it was all as it should have been.
One more here. Let's go in the front here.
How soon before we see a private company put a man or a woman up into space?
You'll have to ask Mr. Gerstenmaier that.
Okay.
Well, we've been kind of planning for late 2017, probably December 2017 from the U.S. from a NASA commercial crew standpoint. That's what our request for proposal is asked for from our providers, and we believe that's achievable. Not from Walrus. Yeah.
And if you're asking about other commercial passengers going into space, you'll have to ask those companies how they're doing.
Yep.
Most of them are out west.
Okay, one final question in here, if anyone has one. Let's go right here. Keith?
The black shirts had his hand up.
Okay.
DOD at the Mercury. Eric Langer, my question is, can you elaborate a little bit more on the partnership you have with NASA and the education community, high schools, colleges, and that, and how corporations can participate in that, and what kind of projects do you have coming up? Thank you.
Sure. We have an education group at NASA that kind of does overall education activities and can kind of put you in touch with, if you're interested in doing some things with NASA. You know, Rachel the PAO team can get you in contact with the right education folks. We also, the Center for Advancement of Science and Space, the CASIS organization, they're managing a portion of the space station for us, and they do some experiments with students and with high schools, and that's another avenue that you can contact them directly if you're interested in getting your high school or your college or even junior high. We have some junior highs involved with doing some experiments in space. You can do those activities through them if you want to fly something. And then there's, underneath the CASIS organization, there's a NanoRacks group that also does some science and student experiment kind of thing. So there's many avenues. Probably the easiest one is to reach out to the NASA Education Office and get in touch with them, and then they can kind of steer you the right way depending on what you want to go do and what you're interested in doing in terms of classroom and education and products. It's kind of exciting when some of the things we fly on station, they can actually be demonstrated on the ground, and students can kind of compare results in their own classrooms with what's occurring on space. We've flown some ants, we've flown some butterflies, we've flown some interesting things, and it's kind of interesting to see how the terrestrial equivalent performs on the ground compared to what's occurring in space, so the students can get a chance to see and understand what the microgravity environment's about. I'm also continually amazed by the inquisitiveness of students and how they really grasp the uniqueness of space, and sometimes they ask more, I would say maybe intelligent isn't the right word, but more inquisitive questions than I get from the typical researchers. I think by the time you've become an experienced researcher, you have this 1G bias where your mind always thinks in one gravity, and you don't really ask those interesting questions. And you know, one of the students on the butterfly experiment, you know, and there was another one where a student did it was a spider, a jumping spider that uses, it actually jumps to capture its prey. So the student just quietly asked, well, what happens if there's no microgravity? Would this spider, it can't jump, it's just going to float, right? Is it going to walk over and get its prey, or is it going to try to jump? And those kind of questions, although simple, they get your mind thinking about what's going on in space, and they can actually make you think about how you can use space in new, creative, innovative ways and actually become more innovative. So there's a uniqueness of working with students that is really fun. They're not inhibited by being embarrassed by asking the dumb questions. They ask questions the right way, and if you're really intuitive and you understand that, you can get innovative, you can get creative, and you can see some pretty amazing things happen. So you should get students involved with the education group, and you ought to turn loose that imagination, turn loose that innovation, and we'll see what we can do with this microgravity and the space station we've got on orbit.
If I could add just a little bit, I think what Bill is describing is what I would call unconstrained curiosity. And the students really do look at things differently, particularly the younger ones, and some of the older ones too. But there are organizations that, many of them not-for-profit, that conduct space camps, academies, weeks where students can come in from various places and build their own experiments, and then CASIS and NanoRacks and others will organize the ability to get them onto the space station. On our last mission, we flew several, and we had students here who had designed experiments that flew on the station, or on Cygnus to the station. We had some slime from King's College, I think it was, and some other places, and these were the selected experiments to go. But there are lots of these organizations, you just need to get online and look for them, who are helping students open their minds and explore space in a real way. And then they get the data back, either pictures back or real data, and occasionally actual results. So it's the way to inspire children that and young adults that space is something everybody can have access to eventually, at least through what's happening on the space station. I think it's very important that we continue to motivate people into the science, technology, engineering, and math arena.
Okay. Well, that'll do it for us. I want to thank everyone very much for joining us today, especially Bill and Frank. Cygnus is set to arrive to the space station on Wednesday. We'll begin our NASA TV coverage at 5:15 a.m. for a 6:39 a.m. grapple. You can follow the latest information on the Orb-2 mission and find out more about the International Space Station at www.nasa.gov/